There is a new fun space cartoon that crossed my path this week. A pair of meerkats traveling through space are stranded on a strange alien planet where they decide to spend their vacation. I suspect it would be quite a bit more fun to watch if my Spanish comprehension was better. But the real meerkat of space shared some astonishing news a week or so ago. This is Meerkat. The South African Radio Astronomy Observatory, SARAO or SARAO, is constantly pushing the boundaries of innovation in radio astronomy. Their cutting-edge digitizer technology is a key component of the Meerkat telescope, transforming signals from outer space into digital data for in-depth analysis. Recently, astronomers using the Meerkat radio telescope at SARAO released the news that they had detected the most distant Hydroxyl megamaser ever observed, a cosmic laser emitted from a galaxy more than 8 billion light-years away. The discovery was detailed in a paper accepted for publication in monthly notices of the Royal Astronomical Society letters, with a preprint version available on RX, which is ARXIV. So my first question was, what exactly is a hydroxyl megamaser? Hydroxyl megamasers are natural phenomena that emit exceptionally bright radio waves when hydroxyl molecules in the gas-rich regions of merging galaxies collide. These collisions compress the gas and trigger the molecules to amplify radio emissions in a way similar to how lasers are produced on Earth, but at much longer wavelengths. The newfound system, located in a galaxy that is 8 billion light-years away, is the most distant hydroxyl megamaser ever detected, and its intensity qualifies it as a gigamaser, a term used to describe the brightest and most powerful space lasers. Here's a beautiful, almost poetic explanation of a laser or maser. Quote, "Think of a laser as a light choir, where every photon is singing the exact same note in perfect unison to create a powerful focused beam. A maser is simply its invisible cousin, performing the same feat with microwaves instead of visible light." This is an illustration of the distant galaxy 8 billion light-years away, red, magnified by an unrelated foreground disk galaxy, resulting in a red ring. Splitting up the radio light into different colors, as a prism does, reveals the hydroxyl gigamaser top right rainbow-colored line. This is from the Inter-University Institute for Data Intensive Astronomy, IDIA. In a previous fun fact, we talked about gravitational lensing, where light is magnified by the mass of a galaxy. This was theorized by Albert Einstein and has now been observed many times in optical astronomy. However, Meerkat's discovery represents the first time gravitational lensing has played a significant role in amplifying a radio signal over such a vast distance, offering a rare and unique perspective on cosmic phenomena. A helpful comparison to understanding what the unrelated galaxy is doing is that the galaxy acts as a lens the way a water droplet on a window pane would. Its mass curves local space-time and amplifies the radio laser. Now, from South Africa, we head over to Denmark. Yes, Denmark is in the news again, but not because of its relationship with Greenland. Remember Tycho Brahe, who I thought was the most famous Danish astronomer? Well, actually, he is not even listed in the Pantheon World List of top 10 legendary Danish astronomers, but that's another fun fact for another time. Regardless, Brahe, along with other famous Danish astronomers, made great contributions to astronomy. Just last November, Denmark's Ministry of Higher Education and Science published its proposal for the largest public investment in space to date, 2.7 billion kroner for 2026 to 2029, to expand research, technology, and European cooperation. That is equivalent to over 560 million Canadian dollars. For a country with fewer than 6 million citizens, Denmark also plays an outsized role on the world stage when it comes to sustainable development and the fight for human rights. Here's a stunning fun fact. For 40 years, Denmark has met the UN target of setting aside 0.7 of GNI for development assistance. Only a very few countries in the world meet this target. I'm a little ashamed to see where Canada is on this list, but at least we are on the list. And now, how about this? Yes! On February 8, 2026, motorists traveling through Gladsaxe, a municipality located just outside Copenhagen, began noticing a stark visual shift along a specific stretch of road. The familiar blue-white glare of standard city lighting had been replaced by a deep, saturated crimson glow. The installation was strategically placed near a known bat colony to mitigate the impact of artificial light on the nocturnal ecosystem. By shifting the wavelength of the light, the city sought to maintain essential road safety for drivers while protecting the natural behaviors of local wildlife. If such consideration can be shown for bat and wildlife populations, perhaps this red light strategy will catch on and will become a global change, benefiting not just wildlife but astronomers too. Maybe someday we will go from this to this. And since red is the complementary color to green, and I am Irish, I would be greatly remiss if I did not send some meerkat happy St. Patrick's Day wishes to all.